Welcome to Brain Vision.
Okay, so we know the rate of internal energy change is equal to 0 in this case. So therefore, have E dot in is equal to E dot out. If we expand it, we have M dot H1 plus Q dot in is equal to M dot H2. So M dot here is the mass flow rate for the water, and H1 is the enthalpies at the beginning, okay, which is the inlet enthalpy. And Q dot in here is the heat inputs, which is the heat that was transferred into the system, okay? And H2 here is the outlet enthalpies in this case, okay? So if we do some arrangement here, eventually we have Q dot in is equal to M dot times Cp times T2 minus T1. Since H2 minus H1 can be expressed as Cp times T2 minus T1. So Cp here is the specific heat for the water, and T2 is the higher temperature, or the temperature at the axis, and T1 here is the lower temperature, which is the inlet temperature. So now we know the mass flow rate is given as 0.2 kilogram per second, and the specific heat for the water is 4.18 kilojoule per kilogram times degrees Celsius. And we know T2 is 60 degrees Celsius, T1 is 25 degrees Celsius. So now we can determine the rate of heat transfer in the heat exchanger, which is the heat inputs in this case. So the rate of heat input, which is the rate of heat transfer, can be equal to 0.2 kilogram per second times 4.18 kilojoule per kilogram times degrees Celsius, and then times 60 degrees Celsius minus 25 degrees Celsius. And this will give us the rate of heat transfer in the heat exchanger is about 29.26 kilowatts. And now we can determine the exit temperature of the geothermal water, okay? So, which is the T out here. So T out can be equal to T3 minus Q dot in over M dot 2 times Cp. So I have T3 is given as 140 degrees Celsius, okay, which is the available temperature from the question. And Q dot in is the one which is calculated, which is 29.26 kilowatts. And we know the mass flow rate for the geothermal water is given as 0.3 kilogram per second, and the specific heat for the geothermal water is 4.31 kilojoule per kilogram times degrees Celsius. So now let's plug in back to the equation to determine the exit temperature for the geothermal water, which is equal to 140 degrees Celsius minus 29.26 kilowatts over 0.3 kilogram per second, and then times 4.31 kilojoule per kilogram times degrees Celsius. And this will give us the exit temperature for the geothermal water is about 117.4 degrees Celsius. And these are the answers for this question.